So for example number 1, for example number 1, we're going to talk about transforming sine. If we think in terms of y equals a times sine of x, where a is a constant, in other words, it's a number, the a term does the vertical shrink or stretch, right? That's how it's always been when we transform functions. So nothing is different here. And so I want to talk to you about, I want to talk about a couple of things. We also call that the amplitude. And so because it's a wave function, I'm not quite sure if we call it amplitude. For sound waves and light waves, we can magnify the waves, and we call that an amp. That's where the word amp comes from. So if you have an amp for your car stereo, you're amplifying. What you're really doing is increasing the amplitude of the sound wave. To some degree, you're making it louder. Same with light waves and intensity. We'll talk about that more in physics in a couple of weeks. But basically, right now, I have y equals 1 times sine of x. Okay? And if you look at the graph, and I'll zoom in just a little bit. If you look at the graph, whoops, I zoomed in a little too much. If you look at the graph, what you see is it has an amplitude from 1 to 1. Now the amplitude, the number, is how far do I go from the center. So if I have this little centerpiece here, like this is the center of the wave behavior, the amplitude is the max or min. So to go from here to here, a equals 1. Does that make sense? Now if I change that number to 2, guess what the amplitude changes to? 2, because I'm just multiplying all those y values by 2. We said that the range was negative 1 to 1. Well, if I multiply those numbers by 2, then it stretches it out, right? So if I change, this is what example number 1 is, if I change this to y is equal to, and they did cosine, so let me switch that out. Cosine's the same thing, but if I switch that out and they say cosine of x, and then they say 1/2 of cosine of x. Well, let me just change it to 2, so I'm going to use a little bit different number. So if I say 2 times cosine of x, it's the same function, but now it stretches it out vertically. Now it has an amplitude of 2. It goes from 1 to 2. Okay? What do you think happens if I switch that to a negative number? Like say, what if I do something like y equals negative 3 cosine of x? Does anybody here know? Take a guess. Yeah, so what I'm going to do, it stretches it out to 3, but when I do the negative, it does something else. So I'm going to pencil this in. And now we're going to watch how it transforms. I'm going to go back to 1. Now I'm going to go to 0, negative 1, negative 2, negative 3. What did it do? Just like before when we transformed functions, like polynomial functions, when we had that negative leading coefficient, if it was negative, it flipped it upside down, right? Same thing with sine and cosine. When you put that negative, remember that the function evaluates a y value. So if I put a negative number in there, all my positive y values now become negative y values, and all my old negative y values become positive. So it flips it. And then, of course, like she said, now my amplitude is 3. Is there any questions on that? Okay, that is example number 1. I'm just going to crank through, well, no, let's just stop here.